Good Friday morning. Well, today we're looking at a not an issue, but a potential workflow to make a sine plate strap for this device. This is a sine plate, and we're making a sine strap for this sine plate. I am not a machinist, so I'm not fully, I don't know about this stuff very much, but I'm going to try to read between the lines and get it figured out. So from some of the pictures I've seen, these devices have a strap for locking the position once you figure out the angle you want, and you figure out the angle by putting blocks in between this round point on its tangent point and this flat edge, and as you stack blocks up in here, it changes this height which, using the sine function, you can figure out the angle, and that's what this plate's for, so that you can have a strap that lock it into position. And I've seen the strap go this way, and also I think it can be reversed and go this way. Again, I've never used one, so I'm not sure why exactly, but we are gonna try to use some good geometry to make it work out. So let's just see what the OP had to say. I picked up a 5-inch sine plate, but the locking strap is missing. I have no clue how to design one to cut out. Dimensions, arc angle, etc. I don't have a copy. Scoured the interwebs. Brain hurts. Any thoughts? And Jim shared a picture of a sine wave vise, which is similar to the one we have. It looks like this strap can be turned to go this way too, maybe so it's not in the way. I'm totally not sure. Anyhow, this is very similar. Jim shows some assemblies in Fusion, sketch assemblies in Fusion 360. Showing it again here. Just, this is a great way to model and figure stuff out. It's exactly how I'm going to do it. All right. More pictures. It looks like it might follow my original idea, get a measurement when we're close. And then I suggested maybe just scanning it. So the OP there scanned this plate, which gives me with a camera taking a picture, you have the issue of perspective. You kind of do with the scanner anyways. But we want to try to eliminate perspective. That's why using a flatbed scanner is a really good way to go about it. So he's placed this on a flatbed scanner. Maybe a little less typical of a thing nowadays. We were going paperless, but and I requested that he put a ruler on there and scan it at the same time. And this gives us a fantastic reference with almost no human error in it, because the person has to set the object on the scanner, set a ruler beside it, scan it with whatever settings, and then we can calibrate it off this ruler. So I have a whole bunch of different data points that are going to be basically perfect in Fusion 360, and I didn't have to take any measurements between them. I don't have to worry about that. Plus, this thing could be a little open, a little closed. It could be turned on the bed a bit. So, yeah. So I did take this picture, and I've already converted it using Converto from a PDF to a PDF to a what the hell is that file format? JPG, and so I can use it in Fusion 360. Let's keep running down this. So the scan was provided. I said, yep, tomorrow morning I'll start the video, which is now. Then the OP worked up a cardboard aided design. But yeah, crude but close, which is this. I mean, this is also a phenomenal way to do it. And then you would also just take this part, this cardboard part, put it on the flatbed scanner, and go from there, and that would work great as well. A flatbed scanner in conjunction with field-made templates is amazing. So, and this is my post about this topic. So let's start by looking at Jim's model that he sent me of this. So this is the model of the sine plate. All right, and I'm certain he made it off the canvas. Yep, that's great. I just want to see what kind of calibration we have. I'm sure we use the calibration tool, so it's going to be good. And look at that, deadly. There's some shift that looks like may have happened here, but it seems like we have some functioning joints. Let's see. We got a rotational joint here. Come on. What am I grabbing here? Oh, it's a stupid in front of me. Let's get rid of that canvas and stuff so I can see what's going on. Oh, because I'm still in the sketch. Alright. Our joint revolves. It's great. Stops when it needs to. It's great. It looks like maybe we had a jump though when we did this rigid joint here. Let's take a look into that. I'm going to start right at the end at the capture position mark, which is there. And let's go right to the beginning actually and just play through this. See the steps that Jim went through. Perfect, and then we had that jump there for some reason at the end. It moved it. Let's go to the end. I just mean in comparison to the canvas. This jump here. Oops. Rigid joint wanted to grab there for some reason. Just kind of threw off the geometry of the project a bit. But either way, it's totally a functional drawing. Yeah, no, that's great. I am going to just start one from scratch just to go through the motions, but no, this is totally workable. All right, so we're going to start a new project. Good workflow dictates that we save a project before we get going. So we're going to call this sine plate locking strap. I'm just going to put forum example so I remember why it's even in my archive later. Okay, save. Now that we started that, really the first thing we need to do is insert this canvas. And I'm going to, it doesn't really matter where I insert it, but I'm going to insert it in the Z, or I should say YZ plane. And that picture is upside down compared to how that block would be in reality. Okay. Perfect. Now let's calibrate this canvas right here. Calibrate. So I'm just selecting 2 known points, which on this ruler I know exactly what these points are. And I'm going to write in the number 6. So now it's calibrated the entire rest of this canvas. And we can start figuring out our points. So, to me, looking at this sine wave problem, I shouldn't say problem, this sine wave project, the way one might have to deal with this is, let's just start plotting out stuff we know. We know we have a circle here we're going to need to deal with, and I know I'm not perfect here and it doesn't matter currently. So I'm going to go and did you see how it was trying to start a constraint there? And I didn't want that. So here, I'm just making a circle. But if I go in here, you see how those blue... Let me zoom right in. See how those blue lines appear like that? If I make my circle while those blue lines appear, it will attach 2 constraints to it. So I don't want that. So I'm just going to make sure my circle is not constrained. Perfect. Here, let me give you an example like that. So about, let's say it is circled here. It's wanting to constrain it off that line type. And I don't want that because I don't know if the centers are right, or so I just want to be able to move these freely without them trying to lock into positions I don't need them to. So I'm going to go and equals all these because I know all these are the same size. Alright, I'm just going to get these to the very approximate size that they're at. Keep forgetting you're going to grab from the middle to move it and the outside edge to change the diameter. Alright, we have those lined up, a little smaller. There's the holes. Perfect. Let's get this one as close as we can to that's pretty damn close. Alright, so I don't know how open this is. Looks like it's already open, maybe a degrees or 2. So we need to figure out a way to have that not be taken into account. So let me unzoom here. And I'm going to start taking some diameters off these things just to kind of figure out where I'm at. And I'll make sure I just use construction lines here. So I'm using a 3-point circle right now because I care about the relationships between these arcs and the other arcs. Now, what I'm going to do is take a 3-point arc. I just want to be able to get the center line. Yeah, forgive me here while I'm kind of figuring out what's happening. What I'm going to try to do here, that might screw up everything, I'm going to try to that makes sense. I wonder if I can rotate those other two. I'm just trying to make my geometric model work the same as the sine wave plate would work, or sine wave plate, sine plate. Move, I'm gonna go to rotate. Look at that, absolutely deadly. Perfect, that's what I want. Good, so that looks like the actual geometric, but it's not parallel. It's okay though, I want it all lined up center-wise like this. That's interesting. You can clearly see how this one is moved in from the edge slightly compared to this one. And I'm wondering if that is so they can get some negative angle out of this plate, or you have a little bit of extra, so you can start your zero at actually zero. I just don't know enough about these objects. What I do know though is this point here is an important point for how we pivot to here. So, because these angles aren't just a smooth slope, because we're not going from here and sliding, we're going from here. I don't know, it's kind of a weird, I was trying to think about this last night a little bit. So, let's see if I can figure this out. So as this one rotates, I think I want that arc. Let me just build another circle over here. And I'm going to try to tangent constrain this circle into just a few locations. And just see if that's going to give me the geometrical references I want. Tangent constraint, please. Sorry, we're just having a thought here. I'm going to just bring out the 3-point circle. I want to take a look at something. Let's get an arc in here. I'm going to tangent constraint this arc to this arc. Oh, is that correct? It seems like... And as it pivots up, it should pivot between here and here. Okay, let me try that strap location to start with and see if that's in the realm of making sense. 3-point center slot. Let's go here. And I want that slot to go a little bit past. And I'm not sure exactly how long it needs to be. It looks like this sine plate doesn't have a stopping point, so it can keep going. Let's go to about 70 degrees. Let's just go to about here. I'll do about a 1/4 inch slot, let's say. I'm going to do another slot. Maybe just go to a full half. Let's see what that looks like. Gives me an 1/8 on either side. That's a little small. Let's try 5/8 and we'll have 3/16. Sure, that's enough for a washer and a bolt. Okay. I'm going to use the center point slot again. This is going to be my center this time. I may be crazy, but I think that's gonna actually function well. Let me extrude this now. Let's say it's 14 gauge. Gives you a great range of travel. This center point where it where it pivots should try to maintain center access with this point. All right, I guess I could make a couple pieces and just lock it all together and see how it moves, but I think that's pretty close. And then it should be able to actually be used on the other way from here to here. Okay, let's build some more parts here. Let's bring up this, well, the scan's already up, but let's bring up that last set of sketches. All right. And, okay, let's project some stuff. That. I don't really need that one, but let's just do it anyways. And I'm just gonna roughly do this, so I'm not gonna get it too crazy. All right. Just extrude a few pieces here. We do not want to join, we don't want a new body. Probably want a new component, actually. That's what I should have done with the strap too. Okay, let's now do the other piece. Extrude again. And I'm just gonna extrude that piece by itself at minus, what did I go, ½ inch? No, with 3/8. And do another component. Okay, let's make this thing into a component. Nope, not all that stuff, just the one thing, please. Where are ya? Alright. Let's join some of these pieces. I'm gonna join this to this. Okay. I just want to see how it works. I'm having a problem grabbing onto things today. Just trying to grab through everything, I think. That's not moving it correctly though, but let's get this canvas out of here. Canvas, let's get the sketches out of here. I don't think I joined that correctly. Edit. Delete that. I want to change that joint. I'm going to start with this one. And not like that. Let's start with this one. No, where's the other flip? Between two faces, between two faces. Flip. There, thank you. Okay. Yeah, that's a little bit more reasonable. Let's ground this one. Ground right here. Oh, it didn't put my holes through either. I wonder if I have to make a pin for that to work. I thought it would just lock in air the way I want it to work. Huh. I'm gonna go back to here and fix this. Oh, I guess I gotta go back and fix the sketch. I can already tell this is not gonna... I don't do joints very often, so... Where is it? Right here? Edit. Project these. Okay, finish sketch. Now I should have those joints when I do it here. Nope, next one. Right here. Sketches, please. This. Thank you. this needs to be jointed. Oh, I don't want it joined out like that though. I almost need a pin in here now for it to capture. Oh, I'm so dumb. No wonder nothing's working for me, right? How about we put in a revel joint? All right. So I'm going to put a pin in here so it wants to keep all this at the same time. So let's do that. Okay. I just want this first sketch. And let's project this. Thank you. And let's extrude a little bit of a pin. And we'll make it not a new body and a joint part, and we'll go from two sides, symmetrical, and there we go. Oh yeah, that's how big I wanted it. There we go. Let's see if this does. Oh dang it, I was hoping that would interfere with that and push it. See, this is where my lack of knowledge in this starts showing through. So I can move this, no problem. Move this, no problem. But how can I make it so these two joints interact with each other? You can see how this would lock at any position. So you get up like this. Oh, maybe I'll need to make it a little longer. Get up that high. I guess you're typically not going that high, but how high would it go? I know some of them only open to 60 degrees. So what kind of angle is that? So we probably want to go at least 60. I'm gonna have to look that up. Just wondering why that component would not push along the other one while we're moving. And this is just something I don't get into lots. So, tangential relationship. Sure, maybe that's it. Oh, look at that. Tangential relationship. Good thing I know what that word meant. So we don't need to go that far down with the hole, and we can go right to there. So I guess I could make that bracket a little longer. Let's go back to the original sketch. I just want both these points here. Let's see, I just move these arcs. Nope, I don't want to screw all that geometry up. Let's lock this. And then we're going to do that. This one and this one, please. Let's move it. We'll do both at the same time, please. Yeah, I'm going to make a concentric constraint between these points. A coincidental strength. Okay, let's move. I just want these 2 points to be constrained to each other. This point and that point. Oh, thank you. There we go. So when I go like this, I can just extend it without it being a big pain in my... It's going to make me move the move tool. Use the move tool to do this. Oh, there we go. Weird, it's not keeping my weight anymore. Alright, let's just do it with the move tool so it's not going to end up being a big pain here. Move. Oh Lord. Everything is all good. Let's just constrain all this stuff. And then we'll move this a little bit. I'm sure I could have done this easier in 20 other ways, but this is the way we ended up doing it. Let's just extend this a bit. No, that's just not going to happen, eh? Sometimes when you don't have a fully constrained model, this is what happens. I want it just a little longer. How am I going to do that without adding 1,000 constraints to this? I want this constrained. So let's constrain what I know is not going to move. These are going to stretch, so I can't constrain those. Now I will grab all those and hit the move key. Use this as my rotational axis. Oh, I hate you so much. Just didn't want to have to go through a million steps here, so move. Oh, you are going to move for me. Okay, let's constrain this. And now let's move dish and dish. This is why I thought the revolve would work awesome using that as the center point. And it's just something off there. Oh, so weird. I'm gonna take that. It's a little bit longer, okay. Let's go back to how that extruded. Edit. Okay. And back to how it extruded again. Edit. Okay. And one more time, because you know when you're rushing through things, this right here changed, so our geometry's fucked. Okay, excuse me. Yeah, that's what I thought. So, instead of messing around the way we had been doing it the last while here, we're gonna just extend it, because I'm not gonna mess around with my over-constrained thing anymore. Right. Look how easy that was. That's exactly how I should have done it. Finish. So now we'll go over here and fix this one. Edit. Okay. So it's a little bigger now. Let's try this bracket. I guess you'd crack. Oh, not quite. You'd want it. Oh, that's why it's truncated like that. Because they're smart enough to know when this crashes out, you don't want that hitting the plate. Okay, that's fantastic. And I understand that now. That's why it has that weird little bit on there, capture position. So what we're going to do here now is we're going to project this. Okay. I'm going to put a line here. I'm going to use the extend tool. Well, of course, that's not going to work. So we're going to use the parallel tool. Okay, let's offset that just a little bit so we have some clearance when it's down in its 90-degree position. Good, good. All right, let's project this. Okay, and we're going to extrude. Turn off all the other sketches. All right. And that's probably why some of them have a little less angle to it. Yeah, there's a lot of design involved with these straps. It's kind of cool. Offset. Just go 3/16. Okay. Extrude. Let's soften those edges. No, I don't want to do those ones. I actually have an idea for those ones. Let's just put a small 8 on it. Is that too much? No, that's good. Yeah. And let's go back to this sketch. And now from this sketch, I'm going to do this. Help keep that bottom stiff. Let's do a tangential constraint here, here, and here. Perfect. You know, it'd actually be cool. Let's just round out the end, just like it was. And we just know this is as much as we can go. We don't need to do a weird. And I see why they did it, but we absolutely don't require it. All right, extrude. And let's just extrude one more time and get rid of this, and this, and this, this. All right. Oh yeah, that's good. Yes. Oh, and at 0, it shouldn't go past the plate, and it can go up to not quite 90. I imagine switching some of this stuff around would help. All right, well, I'm not sure. I guess you could, with this model, you could try some geometry with some different brackets if someone wanted. Modify the geometry of that bracket some more. Yeah, I don't know if you'd want it above the work surface like that, though. You know what? Let's try just a really radical arc on there. What time do we got here? How long have we been running? 48 minutes? Yeah, we can go a few more minutes. From here, what I'm going to try is, let's try a really steep angle across this. Project, please. Okay, I kind of see what's going on with these now. That lowest position, it just hangs over, and the rest it seems okay. So let's go run with that. And one more slot here. Going to be away from the computer a little bit today. I've got some service calls and such to take care of. Nothing major, just basic service. Alright, oh, little notchy-roo here, let's get that. Alright, now, let's join this. It's gonna make a conflict with my old joint. Oh no, let's just get rid of that old joint. Yes. Yes. Change the relationship of that joint to revolute. And I need to get in here and add that up there. Under assembly though, under tangential relationship. And again, thwarted by not turning that into a component. I should have done new component, not new body. So my workflow isn't awesome for sure in this space. Tangential, yes, and yeah, thank you. Okay. What the hell are those pinned together for? I feel like I must have accidentally tied those together somehow in one of these steps. But let's repin the, oh, because I destroyed the relationship between it and that. Let's repick that up. Sorry, I don't really have a center for this. All right. And revolute. Okay. And everything's stuck now. Good. Did oh, that tangential constraint, does it exist still? This shouldn't matter, it should move anyways. Perfect. So we got some kind of, oh, that works fine. Anyways, I wrecked my joints here, so that's awesome now. But this one's still grounded, right? Yeah, it's got the pan. Why is this tied to here? Did I wreck it somewhere along here? I made an error somewhere. Damn, my hand's going numb too. We're going to figure this out here, because I know this is going to work a lot better than that previous model. Let's try that tangential constraint again under assembly. Tangent relationship. Oh, there you go. Sure doesn't like me moving that one though. That's okay. Nice. As long as I can get over 60 degrees, that's going to make my life happy. And that it doesn't plunge below here. Oh yeah, I can go lower. That's not bad. Anyhow, that's yeah, another bracket. So I'm gonna post this Fusion 360 model. Yeah, you can try a number of brackets there. There's the other one if you want. This bracket should be able to be used the other direction too. Should we try that? Sure, let's try putting this bracket in the other direction. Get rid of this joint. Let's not get rid of that joint. And then I'm going to go before the tangent constraint, and then I will assemble this a little bit differently. We're going to go on this face, and then on this face. But then we're also going to flip, and we're going to use revolute. Okay. This should be able to move decently. Yeah, no problem. I'm going to go in here now, and well, first thing I'm going to do is capture position. I'm going to take this pin and just put it to here, while also suppressing component 4. Okay, now I will make another pin here. Oops, finish sketch. I actually didn't want to do it in that area. I want to do it over here. Okay, and let's put a pin through here. Alright, we have a pin. Let's bring back component 4. We're going to apply our tangent relationship to this pin and that. Okay, and let's see if we have similar action. Yeah. Well, except it stubs out right there, which means you have to kind of adjust that relationship a little bit more. Not minding this though. See, I can work that way. So it looks like though we'll bottom out here. So let's change this a bit. Center slot. At 0.5. All right. Just gonna go like. Let's try that. Finish. We had an issue there because of the extrusion part. Let's go to edit extrusion. Just new pattern instead. Okay. Downstream features. Okay. Well. Cannot compute relationship terms because it's affected by downstream. You inspect the downstream features that affect the geometry and consider them before tangent relationship timeline. Okay. Let's try it now. Interesting. I'm going to delete everything past this marker. Let's get this constrained normally. Let's throw that tangent constraint on here. Okay. There. That actually works great too. Nice. Let's see if we can get up to 60 degrees. Oh, I was going to say something's preventing me from moving it anymore, but it's because of this stupid seam. So when I did that tangential relationship, edit. It got up to this part of the seam. Okay. There. Now it'll let me do the rest of it. Now that's just to there. Yeah, it's because it split that circle up into 2 pieces. And I'm sure that'll just keep going. Anyways, let's see how close to 60 degrees that is. 48. That's going to do 60. Okay. Well, so this is would be the part in question. I mean, you could try a bunch of different styles of geometry on that. I will attach this kind of crude model to the topic on the Langmuir site. You guys have a great Friday. I have a busy day of service calls and study ahead of me. Take care.